Hello, so let us start the lecture on ILD for reaction at B. So we are continuing the same problem. So what we have taken earlier, so that what was the problem? So it was a continuous beam with 5-meter span and 4-meter span, and it was told to have the interval of 1 meter. So in this case there will be 5 intervals, as it is 1 meter, 2 meter, 3 meter, 4 meter and 5, and in this side there will be 4 intervals. And as I told you, it's 1 by 5 is 0.2 will be the interval, and here it is 1 by 4, that is 0.25 will be the interval. So and now we have to draw the ILD for reaction at B. So what is step 1? Step 1 is ILD for determinate structure and divided by EI to get the determinate displacement, divided by EI to get determinate displacement. How to get the ILD for determinate structure? You have to make it as a determinate. So for that you will have to create a hinge here. So what will happen by creating hinge here? So it will be this will be 1, and then you have this ILD. Okay, so that means this will become 1 by EI displacement, and then you have to take 5 intervals, 1 2 3 4 and 5, that is this is 1, then this will be 0.8 by EI, this will be 0.6 by EI, this will be 0.4 by EI, and this will be 0.2 by EI. Okay, this side there will be 4 intervals, so that means 1 2 and 3, that is 0.75 by EI, then this will be 0.5 by EI, and then this will be 0.25 by EI. So this is nothing but determinate displacement. How do you get determinate displacement? We provide hinge and make this indeterminate structure as a determinate, and we pull it by 1. So that way you get the ILD of determinate structure, and divide it by EI to get the determinate structure. That is step 1. What is step 2? Step 2 is, because of this determinate structure of 1 by determinate displacement of 1 by EI, what will be the fixed end moment generated, and because of that what will be the end moment generated, that we have to calculate. Now let us take AB span. So if you see AB span, the displacement is in this direction, so you can see it will look like this. So it is like this, and because of that you can note what kind of end moments are generated, that is 6 EI delta by L square and 6 EI delta by L square. And what is this delta? Delta is 1 by EI, and that's why this moment will become, and L is 5 meters, so it will become 6 EI into 1 by EI divided by 5 square, and that will be 0.24. and note here both are going to clockwise, that's why this is positive. Whereas in case of BC span, what is the situation? BC span, it is happening like it is this way, situation is there, and that's why the moment generated will be anti-clockwise, and it's the same 6 EI delta by L square, 6 EI delta by L square. And please understand the delta is 1 by EI, and span in this case will be 4 meter. So the moment, fixed end moments generated will be what? They will be 6 EI into 1 by EI, delta is 1 by EI, and divided by span is 4 meter. So if you put that, so you will get 0.375, and please understand they are going anti-clockwise, that's why negative. So and already we have calculated the distribution factor for this span. So if you see distribution factor for 5 meter and 4 meter interval, that is nothing but 0.44 and 0.55 we have already calculated. So let me just quickly show you how we have calculated. That is 3i by L divided by 3i by L plus 3i by L. L is 5 and 4. This is 5 and 4 meter span, and that's how we got 0.44 by distribution factor BA and distribution factor BC as a 0.56. So we will take that same distribution factor because our structure is still same as that of previous problem. So we'll continue to save time. Distribution factor is 0.44 and 0.55. This is simply supported, so 1. And then let us put this is clockwise, so 0.24, 0.24, these are FEMs. And then this is anti-clockwise, so minus 0.375, minus 0.375. And then now next step is balancing. So let us balance it. So if you balance, it will become minus 0.24, and then this will become plus 0.375. And if you balance the difference between this, the difference will come as a negative 1, and that's why we'll have to be positive, multiply it by 0.44 to get 0.059, and this side it will become 0.076. And similarly then you can do the carryover step. These two things will come here, so carryover will become minus 0.12, that is half of this, and carryover of this will become plus 0.188, that is half of this. So and then now if you take the difference, again the difference is positive, and that positive difference will be balanced by this, so which is nothing but minus 0.0297. If you have studied moment distribution method, you can understand this, 371. And then you can see now balance took place. You can just add, this will be 0, and if you add this, it will come as a 0.149, and this will come as minus 0.149. And then you can use this to understand whether it will create, this is m value for our calculation in step number 3. So it will be 0.149. Now whether it will create positive or negative bending moment, that we have to understand. Now this is going what clockwise, so this is positive, so going clockwise, so this will push in this direction, that is this will go clockwise, and this is pushing anti-clockwise, so that means this will lift the diaphragm and it will create positive effect. This will lift the diaphragm and it will also create a positive effect. Okay, and then if you see in previous example, we had got the negative values. We got the negative values, and that negative values, how we got negative values, you can see the moment distribution. In the previous example, this was negative and this was positive, and that's why it was going anti-clockwise, and this was going clockwise, and that's why we got negative. Whereas here it is this side values. If you can compare this, how to compare, yeah, so this is negative, this is positive, whereas this is negative, this is negative, whereas this is positive, so that you will get exactly opposite. So this will be positive, indeterminate values will be positive, and then you can start n is equal to 1 here because moment is applied. So there is a 20% interval, so n is equal to 0.8, n is equal to 0.6, n is equal to 0.4, n is equal to 0.2, and 0. Similarly this side 25 interval 0.75, 0.5, 0.25, and then 0. And for this these intervals we have already calculated the k values. So how to get those k values, like you can note here, for n is equal to 0, so n is equal to 0, k is equal to, what is formula, n minus n cube by 6 0, n is equal to 0.2, it is 0.32, n is equal to 0.4, 0.56, n is equal to 0.6, and likewise we have to calculate k values, and once we have k values we can directly apply the, now we got the moment, we got the k values, we have to apply k ml square by EI formula. So total displacement we will get, ILD displacement will be nothing but EI into bracket determinate displacement plus indeterminate displacement. Okay, so let us label this y naught and all that, so it will become easy for us. So we will call this as a y naught, y1, y2, y3, y4, y5, y6, y7, y8 and y9. So if you label that, so we can get y naught will be nothing but EI into, so what is determinate displacement at y naught, so this is y naught 0, so we have determinate displacement 0. What is indeterminate displacement? K ml square by EI, and for n is equal to 0 you can see n minus n cube by 6, k is also 0, so that's why this is 0. So for y1, what is EI into what is determinate displacement? This is y1, so this will be 0.2 by EI, 0.2 by EI, and plus k is for this one, for n is equal to 0.2, the k value is, for this case we have already calculated, it is 0.032, so this will be 0.032 multiplied by m value we have calculated here, that is 0.149 multiplied by length of the beam is 5 meter, length span is 5 meter, we are in AB span, 5 square by EI, and if you do that, this value comes out to be, this value is 1 minute, I will write first and then we will write a calculation. So this value is 0.319, this value is 0.319, and then similarly we can do it for the y2. So if you note here, determinate displacement for y2 will be 0.4 by EI, so it will be EI into bracket 0.4 by EI plus what is k value for 0.4, it is 0.4 into 0.4 cube by 6, it will be 0.056, so it will be 0.056 into m is same, 0.149 into span is 5 divided by EI, and this value is nothing but 0.609, and then similarly we'll quickly now write other values you have understood. EI into 0.6 by EI plus 0. K value is 0.064, 0.064, it will be 0.064 into 0. M is same, 149, span is same, divided by EI, and this value comes out to be 0.838. And then if we go to y4, what is y4? EI into 0.8 by EI plus k value in this case for 0.8 is 0.048, so 0.048 into 0.149 into 5 square divided by EI, this comes out to be 0.979, and y5, you can note what is y5, determinate value is 1 by EI, EI into 1 by EI plus K value in this case is 0, so everything will be 0, so EI it will goes and it will become 1. So you can note it will be as we are drawing ILD of RB, so at B it will be highest value, that is 1. Now let's go to Y6. So Y6 will be EI into, what is Y6? This is Y3, Y4, Y5 and Y6. The determinate value is 0.75 by EI, 0.75 by EI. We are going in the other span now, interval is of 0.25 plus, what is K in this case? K for 0.75, that is 0.75 minus 0.75 cube by 6, that will be 0.0546. So it will be 0.0546 into 0.149 into the other span is 4 square divided by EI, and then you can get this value as a 0.88. okay, 0.88. so similarly we can get Y7. Y7 is what? EI in bracket point after 0.75 there will be 0.5 determinate value, so 0.5 by EI, 0.5 by EI plus K value for 0.5 is 0.5 minus 0.5 cube by 6, that will be 0.0625. so K is 0.0625 into M is 0.149 into span is 4 meter square divided by EI, and this value comes out to be 0.649, and then Y8 EI into determinate displacement in this case is 0.25 by EI, 0.25 by EI plus for K is equal, N is equal to 0.25, it will come as a 0.25 minus 0.25 cube by 6, that is 0.039. so it will be K is 0.039 into M is 0.149 into span square divided by EI, and this comes out to be 0.343, and last value Y9 EI in bracket determinate value for this Y7, Y8 and Y9, 0 plus K value is 0, and that's why this is 0. So this way we got all the values right from Y1, Y2, Y3, Y4, Y5, Y6 to Y8, Y9, and you can say this is addition. That's why the kind of determinate displacement will be like total displacement will be more than the determinate value. So you can note here the curve will come as a convex. So you can see here this is RB, you'll have to draw 1, and then this will come something like convex type of curve because there is a addition. So you have Y0 0, then you can have Y1 will be, so we can write from the center it is 1, then this will be Y4, this is Y5, this is Y4979, then this will be 0.838, 0.509, and then 0.319 and 0. So you can see 0, 319, 509, sorry 609, and then 838 and 979. On the other hand, there will be 3 values, that is 0.88 and then 0.649 and 0.343. Thank you. So that's it. This is the ILD for RB.